Welcome to Day 2 notes for Unit 14 for Algebra 2R. You'll notice my answer key is already filled in, so this is me just explaining the notes so that you understand the process that we covered in our Day 2 notes. Today's focus is all about random sampling, and it's used to eliminate bias in our sampling. So in order to do this, we employ strategies of something called a random digit table, which is something that we would test you on. We also can use technology like a graphing calculator to generate random numbers. So here's how it works. Let's say we have 78 students signed up for a field trip to Darien Lake. Sounds fun, right? We will select 10 students to serve as group leaders. So in order to pick the group leaders, I want to be fair, right? I don't want to pick 10 people and have people be like, oh, you favor them, you're having them be a group leader. I want to leave it all up to chance. So in order to do this, what I'm going to do is assign a number to each person, 1 through 78. So I'm going to assign each person 2 digits because I have 2 digits, 78 amount of people. Okay, so I would go around and be like, okay, you're 1, you're 2, you're 3, all the way to 78. Now, I'm going to use my string of random digits, which comes down here, FYI, to help me figure out who gets selected. Now, with me picking 2 digits, keep in mind that there's certain ones that I have to ignore. Like 00 doesn't correspond to a person based on how I have assigned them, and 79 through 99 are also too high. Those are not going to correspond to people. If we come about any repeat numbers, we'll ignore those because we can't pick the same person twice. Any spaces I'll ignore, and if I get to the end of a line, I'll just continue on to the next line. So what you've seen is me showing my work for how to use this random digit string. So I went through and I just blocked off 2 digits at a time. That's what each of these dashes are. It's me chunking and figuring out what the 2 digits are. And I just did a good amount, and then I went back to the beginning of this. And I asked myself, is 27 in the interval of 01 to 78? Because that corresponds to a person. And he is, so that's my first person. Now the next number looks like 81, which is outside the interval of people, so I ignore him. 67 is a person, so he lists. 84 is outside, not a person. 16 is a yes. 1 is a yes. 82 is out, doesn't fit my interval, not a person. 27, well, he is a person, but didn't I already pick 27? So that's why I threw him out. 35 is a person. 21 is a person. 37 is a person. 74 checks out. 10 checks out. Now 16 is in my interval, but we already picked 16, can't pick him twice, and so then my last person is 31. And that's how we use a random digit number or string of random digits to select my people. Everybody had an equal chance of getting picked. It was just however the numbers spoke. So then it's the same idea for this next one with independent practice, where now I'm going to randomly select 10 students, but I have 300 students I'm picking from. So therefore, I'm going to assign everybody a number 0, 0, 1 through 300, but make sure you ignore 0, 0, 0 and 301 to 999. Now, this says beginning at row 25, which is where a lot of students will actually mess up. They read over that. So that means I'm starting with this row right here, the 3rd row down. And now, based on the way that this one is displayed, I actually went through and just circled chunks of 3. So like this is a chunk, this is a chunk, that's a chunk, so that's representing a number. And then same idea. 342 was not in my interval, so I threw him out. But 291 is in my interval of 001 to 300, so that's why that person was selected. 909's out, 816's out, but 253 he's in. 909's out. Now, notice how I got to the end of a line. I just circled down to the next line, so that's 102. And 102 is a person, so he corresponds. So you'll notice I'm just going through, I'm crossing out the ones that don't work, but I'm keeping the ones that do. And remember, you can't repeat. So these were all thrown out. He works, and so on and so forth. And that's how to use a random digit table. And this is how me or the Regents would test you, because it's the easiest way for us to make sure that you can generate the random numbers that we want you to generate. Now, something else you'll have to know how to interpret, though, or understand what we're saying, is using a random number generator in your calculator. So this is not as exciting in a video, but in class, I had everybody come up with a list of random numbers, and I did something called seeding to make sure we all got different ones. Seeding a calculator means you're basically starting at a different row of your random digit table. So I'm going to deliberately put in the number 2017 so that it matches my data that I'm seeing in the notes. So 27 store, and then I can seed by going to math prob, and then it's option 1, which is rand. Okay, so now that I've seeded my calculator, again, I'm not testing you on this, I'm just showing what I did in class. One of the attractions of the All-Star game tested baseball throwing distances. The table below recorded the distances in feet of all 200 throwers. So this is our population of all of our All-Star players. So you're noticing that there's numbers down here. So every person has a number, and so on and so forth. And next to it is their corresponding distance that they threw. I want to randomly sample 10 throwers from the table above. So I'm going to use my calculator to generate 15 random integers between 1 and 200 all at once, and these will represent my thrower numbers, the people that I pick. We only want 10 throwers, but if we get the same thrower number twice, we don't want to use that result a second time, so we'll just ignore it. So the reason I'm generating 15 as opposed to 10 is in case I have repeats. So if I go to my calculator and I type in math probability and then rand int, which is option 5, okay, some calculators will prompt you, mine is not. I'm going to type in 1 to represent my first thrower, 200 to represent my last thrower, and then 15. So again, this 1 is representing the low bound, the 200 is representing the high bound. So this is saying randomly generate numbers between 1 and 200 and give me 15 of those. And then I'll hit enter. So these numbers that you're seeing, the 160, if I hit the sidebar, 71, 111, you'll see these are the numbers matching what I wrote down here. 160, 71, 111. So these were my thrower numbers. 88, 11, 59, 98, 78, bring this over, 119, 161. So I didn't have any repeats, so I just took the first 10. And again, this seeding is like I'm starting in row 2070 or 2017 in my random digit table. So this is how I use technology to randomly get my people. Now, each of these throwers represented a person with a throwing distance. So what I did was I took these throwers, so like thrower 160, he's over here, and I saw he threw 284.9 feet, and that's why that number's here. Thrower 71, I found him. He threw 329.6, so there. And so on and so forth. So I just went to this table and I marked down what their distances were. Now, if I wanted to find the mean distance of all 10 throwers, I just added all of these up and divided by 10. And that's where this number is coming from. So it's just the average. Add them up and divide by 10. That's called a sample mean. So you just found an X-bar. Now, let's say we'll call anything 300 feet or more a good throw. So like he's good, like everything highlighted in yellow is considered a good throw. I have 1, 2, 3, 4, 5, 6 players on my sample, on my team, if you will, out of 10, which is the same thing as a 0.6. So about 60% of my sample, so 60% of my sample is a good thrower. That's called a sample proportion, which represents a p-hat. So this is quantitative data, and this is categorical. You're either a good thrower or you're not. Quantitative is data that's measured with units, like this is the average feet that they are throwing. So if we were to do this in class together, again, everybody would be generating different numbers. In fact, look at this. If I just keep hitting enter, it just keeps generating different random numbers for me. So what that means is every person who would be doing this in the room as well, if there was like 30 of us, we'd all be generating different samples of 10 baseball players and coming up with our own different set of data. So we would all have different X bars and P hats. And that's why on the next page, it'll say, we have seen that samples are taken from population. So this was a sample taken from my population of 200 baseball players. And when we develop our numeric results from our sample, we say we have sample statistics. In formal use, whenever we see the word statistic, that means it's a summary number. So everybody in the room would be generating different statistics based on our samples that were taken from our population. Boop. Okay, in this table is just some what's the word I'm looking for? Variables to pay attention to, like X bar is representing sample mean, P hat is sample proportion. This is mu. You won't see him a ton, but we use X bars to estimate mu, which represents your population mean, and that's a population parameter. Sample statistics go together for vocab. And then we use P hats to represent population proportions, which is just a P. Now, the last thing we did on this lesson was talk about just the difference between a parameter and a statistic. Again, parameters come from the population, so parameter, population, sample, statistic. And we just read through and figured out whether our data was categorical or quantitative, and whether each number was either a P hat or a P. So like for number 1, on New York to Denver flight, 8% of 125 passengers were selected for a random security screening before boarding. According to the Transportation Security Administration, 10% of the passengers at the airport, so that's everybody, are chosen for random screening. So you're either chosen or you're not, so categorical data, it's either success or fail, you're in or out. This 8% of 125 is representing a sample of everybody at the airport. So that means this 8% is representing a P hat, and the 10% is representing of everybody at the airport. For question 2, on Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspectors sampled 50 bottles at random on the day's production. These bottles contained an average of 19.6 ounces of iced tea. So right there, sampled 50. Okay, that's telling you that this 19.6 is representing an X bar. And this is quantitative data because we're measuring it with units like ounces. You have this many ounces in your sample of bottles. On average, though, at the plant, we should have 20, and that's your population mean. So if you were to take all the bottles at the plant and average them, we would expect it to be about 20. And that concludes what we did in day 2. So we talked about random sampling. We did it with a random digit table, and we also did it with our graphing calculator, and just talked about how random sampling will get us to have different samples, which is something called sampling variability, which we'll explore more in lesson 3.